Welcome to Sir Joggy Videos. This video is an GCSE geography lesson on the impact of sea level changes on the coast. The question we're focusing on today is this one here. Using examples, explain the impact of sea level changes on the coasts. Now then, as you can see from this chart here, what we're looking at is how sea level has changed over geological history. And of course the changes are quite dramatic. If you look over here, the scale goes up to 400 meters. Most recently, since the Cretaceous, 145 million years ago, the sea level is said to have been some 200 meters above the current level, which is indicated here as 0. Well, that's over a very long time period. Over a shorter time period, there are also changes. So we need to look at how and why these occur and what impact they have on landforms and the coast in general. Well, before we look at all that, there are 3 causes of sea level change. The first one is called eustatic sea level change, and what this means basically is rather like switching a tap on in the bath. Sea level volume, the amount of water stored in the sea, goes up or down. Now it will go up if, for example, the world warms up and the ice on places like Greenland and Antarctica melts. So that is eustatic sea level change. We also have something called isostatic sea level change. This is a little bit more complicated to understand, but essentially isostatic sea level change is change in relation to the land level. We'll come back to that in a minute. Finally, thermal expansion is the idea that if you warm the ocean will expand, the ocean water will expand, and this is another cause of sea level change. Well, let's look at eustatic change. Here's a chart showing eustatic changes or volume of sea level history over the last 140,000 years, and it shows quite clearly that previous to about 20,000 years ago, sea levels were something like 140 meters lower than they are at the moment. Now this is because the planet was in the grip of an ice age, and during an ice age more and more of the global water is stored as ice on land, as ice sheets, and this means there's less and less water that flows back into the ocean. So sea levels basically fall, as you can see on this chart. Well, when the ice melts during warmer periods, i.e. the last 20,000 years has been a warmer interglacial period, here look, then sea levels rise, as you can see. They have done rather rapidly over the last 20,000 years or so. So most of that sea level rise has been due to eustatic changes. It's not quite as simple as that. We also have this isostatic change as well to consider, because during an ice age, of course, glaciers build up on the surface of the land as snow falls and ice builds up on the surface of the land, and that is very heavy. Some of this ice over northern Scotland was over 1 kilometre thick, as it is today in Greenland and Antarctica, even more than that. So this is very thick and very heavy, and what it does is to squash, it compresses the crust, so the crust subsides due to the weight of the ice. Now that's during a glacial. When we look at an interglacial, of course, the ice melts, it disappears, and the land rebounds. So it's a bit like sitting on a cushion. During the glacial, the ice is like squashing the cushion, and when the ice melts, the land, the cushion, rebounds. Now, the sea around this rebounding land may have risen initially due to melting ice, but when the land starts rising, the sea level will appear to go down. So they work together. Eustatic and isostatic change work in relation to each other. And here they are, as they are working at the moment in the UK. If we take a look, this shows UK mean sea level change. And if you like, this is kind of showing eustatic increase in sea level. However, if we have a look over here, you can see that the land, especially in northern Scotland, is rising by some 1.5 millimetres per year. This is called isostatic rebound. Now, this means Scotland is, if you like, rising out of the sea, whereas down here in the southeast, we're, of course, sinking and sea levels are rising. So the two act together. If we try and show this on a chart, this might be a bit messy, but essentially what we have is, if we draw a little chart down here, there you go, there's an axis, and there's time. Okay, so what we've got is, if we have sea level change going up like this, okay, since the last ice age, so this might be 20,000 years ago. 20,000 years ago. This is kind of now, like that. We've had sea levels rise quite dramatically by something like 100 meters, as we saw on that previous chart. Okay, now this is sea level. This is actual volume of water, one should say. Now, what has happened at the same time, or rather perhaps delayed, is that the squashed land, if we imagine this as Scotland, the land has been squashed and it has rebounded. And in some places, particularly in Scotland, it has rebounded above the rising sea. So the land would have appeared to have risen above the sea. So this is the land, this is sea level. Now elsewhere, of course, like down here, the land is not rebounding, in fact it's sinking. So sea level is rising even more dramatically. We call this whole business between eustatic level and isostatic level relative sea level. So sea levels are relative to the land level, whether it's going up or down, or the actual volume of water in the sea. Okay, so there we go. That's a little bit of background on why they rise and fall. The impacts of this vary, but of course, 8,000 BC or 10,000 years ago, seas around the UK, sea levels were a lot lower. And we were, for example, joined to the continent. There was no southern North Sea. The English Channel was rather dry. We were joined to the continent. So one obvious impact of sea level change is that coastlines change quite dramatically. And during the Ice Age, sea levels fell. Now, of course, we're looking at potentially a dramatic sea level rise. So these are predicted sea level rises in the UK. Note the millimetre scale there. So this is a metre up here. But over the next 100 years, sea levels are expected to rise possibly by up to, well, nearly a metre. Mostly due to thermal expansion, which is the heating of the ocean's surface, causing it to expand and rise. Well, this is one of the impacts of sea level rise. If there were to be a metre rise in sea level, we would be looking at more coastal flooding or inundation around lowland coasts. So, for example, the Thames Estuary, East Anglia, the Wash, parts of Lincolnshire, parts of the south coast, around the Solent, large amounts of the Netherlands, and parts of Denmark. So these little red blobs don't look terribly much in relation to the land, but of course they contain a lot of industry, a lot of cities, important farmland, and so on. So there are impacts in relation to that predicted sea level rise. We may also expect perhaps more flooding, coastal flooding, as we had in 2014 in January with storm surges. And if you add sea level rise to that, you can assume that flooding along the coast will perhaps become more common. More directly to do with landforms, cliffs and erosional landforms are likely to become more active as the sea rises and attacks the foot of cliffs more frequently and perhaps with more energy. So wave energy with deeper offshore gradients may attack the coast more readily, more frequently, causing more cliff collapse to occur in places like Holderness in the northeast. Clay cliffs are already rapidly eroding, but with sea level rise, waves are going to more frequently attack the cliff foot, causing slumping and cliff retreat. So that's another potential direct impact on landforms that exist already around the coast. You could also argue, I suppose, that with more cliff retreat, there's more sediment material available for deposition in certain parts of the coastline. So there's pluses and minuses in terms of this rising sea. Let's look at some landforms which are particular to sea level rise and fall. And to do that, we'll have a look at Google Earth, I think, first of all. So let's take a little look at some of the features of sea level change. Now, sea level rise can flood the lower courses of river valleys, and this creates features called rias. And rias are commonly found in places where sea level has risen into lowland river valleys. And you can see the result here in Kingsbridge down in the southwest. And you can see this is sea, it's not a river, but it's a flooded lower river valley. And it extends quite a long way inland. The characteristic features of rias are narrow entrance and quite steeply sloping sides. Another feature is that they branch exactly like tributaries coming into a river. They have a branching network. They create natural harbours, very nice for sailing, and sheltered harbours for boating and so on. So that's a ria. And we call that a submergent feature. It's called a submergent feature because it's essentially submerged as sea levels rise. It's a submerged river valley. Another similar submerged feature is an estuary. Now, an estuary is a different shape to a ria. It's more funnel shaped, as you can see here. Just highlight the funnel shape. The Thames estuary, typical example of an estuary, here we are, is funnel shaped like this, with mud flats along the side, here and here, of course. So it's kind of funnel shaped, and this is also not that steep sided. It's a shallow lowland river basin, a river mouth, and typically an estuary is a flooded tidal lower course of a major river. So that's what another example of a submerged feature. Other submerged features, perhaps more famously, are fjords. So fjords are steep-sided glacial valleys which have formed as sea levels rise, and they take on a U-shaped cross-sectional profile. And they are submerged glacial valleys. So once upon a time, glaciers flowed down this particular field in Scotland, Loch Linnhe, and created this very steep-sided flat valley floor. They tend to be deepest inland fields because that is where glaciers have most power. They tend to be shallower at the seaward end, where perhaps more deposition took place, and so very often, if you're on a cruise into a field, you'll find the cruise ship slows right down as you enter the field, because it's very shallow, as is well shown on this shot at the shallower seaward end of Loch Linnhe here. So this is another submerged feature, that is a field. And there are plenty of examples of fields in Norway. This one is Loch Linnhe in Scotland, not far, in fact, from Ben Nevis. It's a flooded U-shaped valley. You can see the U shape, if we just highlight that here. Steep valley sides here. Under there somewhere is a relatively flat valley floor, but it's very deep, okay? And then you've got a pretty steep valley side here. So this is a U-shaped valley, okay, which has been submerged. And once upon a time, a huge glacier would have ploughed down here, eroding it. All right, so that is a field. Now, elsewhere, you have emergent features. Now, emergent features are those which, due to isostatic uplift of the land, have risen out of the sea. Now, there are lots of examples of emergent features in Scotland, in northwest Scotland, because as we saw, Scotland is kind of rising out of the sea as ice has completely melted. There's no glacial ice there now, but once upon a time there was, and that melted and released the compression on the crust, and the crust is now lifting up by some millimetres per year, in fact. So what we have here are emergent features, and these emergent features include things like raised beaches. So we'll have a look at a raised beach here. What do they look like? Essentially they are, as you'd expect, a relatively flat area. Now in the northwest Scotland they are often farmed. They're called machair or machair land, and they're rather flat, unusually in Scotland. Flat areas, quite fertile, and they form very good places for farming. So you find crofting communities stretched out along here with pastoral farming and some crop growing as well. So this typically is a raised beach. Now this is a real beach here, and this is the real beach in the Isle of Arran, currently depositing and eroding by wave action. But up here you have the raised beach. So what I'm looking at here is the raised beach. If you look here, the road often goes along it. So this area here is a raised beach. Okay, that bit there. Yeah, there may also be a higher one here, but this shows where the sea was thousands of years ago. And it essentially is not a beach, really. It's a raised wave-cut platform, because behind it you can just see the steep bit in the shadow. That's actually an old cliff. We call it a fossil cliff line, or a relic cliff. And it doesn't look like a cliff now because it's had years of weathering, thousands of years of weathering. So it's vegetated look and much less steep. We'll have a look at that again in a minute. Let's have a look at another area in Arran, which is of an emergent feature. Here's some degraded cliffs and wave-cut platforms. Again, you can see here, not quite as good picture, but you can see here the raised beach along here, like that. Here's the real beach here, but just here, you can see the shadow of it, nice cliff line there. The sea never reaches this anymore, but it is nevertheless a relic cliff, now weathered. Subaerial processes will have weathered it, along with mass movements, and it is no longer vertical, but there are certain parts of Arran where this is, you get quite a good view of these degraded old cliffs. The King's Cave is an example of this, where there are old caves, relic caves. They're no longer reached by the sea. Well, let's have a look at some pictures of this before we finish. Let's start with emergent features. And here you can see various emergent features. So what the land has done here is it's risen out of the sea. And here you can see a number of terraces here, and each terrace, flat bit, is essentially a raised beach from a time in the past when sea levels were much higher. So here, for example, you have, sorry, that's a bit slopey, you have one sea level, here's another sea level, maybe even there's another sea level here. Now, the land subsequently has risen up out of the sea, if you like, on 3 occasions, and left these flat raised beaches, and in a way we should call them raised wave cut platforms. So that's that. Here's another view close up of some fossil or relic cliffs and abandoned caves. These caves are no longer visited by the sea. You can see from the vegetation at the front here, and indeed on the cliff itself, that this is not an active cliff. This is a relic cliff, which means that it is no longer visited by the sea. Relic is spelt like that, and it is therefore no longer eroded. All the activity here is going to be subaerial processes in the form of freeze-thaw, for example, rain action. You can see a little bit perhaps of material falling onto lower slopes here, perhaps a bit of flow here, look. This would be called mass movement. And mass movement and weathering mean that the profile of the cliff is changed from very steep, it's gradually weathered down to a lower angle. Okay, so once upon a time, here you can see the lower bit is still quite steep. Once upon a time it would have all been pretty steep probably, but that's no longer the case. Over here you can see a lovely shot of a raised beach. Look, this is an old raised wave cut platform, and it's agricultural, as you can see. Okay, so that's an emergent feature. Here's another shot of some emergent features. Spot the raised beach. So we have raised beaches really here. Arguably, this could be another raised beach here, look, with a relic cliff here. Potentially another raised beach here. So there's a number of raised beaches here, relatively flat bit, another flat bit there. These are all raised beaches, another raised beach in the corner there, look. So the land is basically rising up out of the sea. Here's the active beach. Don't mix up active beaches with raised beaches. Submergent features. Very quickly, look at a few photographs of these. Here's a ria in Kingsbridge. Confusingly, Kingsbridge is called an estuary, but it is technically a ria. So you can impress your friends with the fact that you know it's a ria, not an estuary. So it's a submergent feature. Here's a fjord, famous one I think this is New Zealand, and it's Mitre Peak here. Very steep-sided, very deep, and typical fjord. Here's what fjords originally were created by, glaciers. Here's a glacier carving off into a fjord, probably Norway, somewhere like that. And here's a lovely example of a very steep-sided fjord here, probably New Zealand again. Very narrow, very, very deep. You can see the angle of the slopes going into the sea there. So there we go. That is, if we go back to our original question, which was, using examples, explain the impact of sea level change on coasts, you should now be able to answer that exam question, drawing some diagrams and perhaps using examples. You could start with something like, sea levels have risen and fallen over different timescales. When sea levels rise, often due to melting ice sheets in warmer periods, parts of the coast can be submerged, forming special landforms such as rias, fjords and estuaries. Something like that would make a jolly good start. Okay, that's enough from Sir Joggy on landforms of coastal rise and fall and sea level change.